Hello, hello. Uh-oh. If we're live, we're not live. What's up? Oh, it's spinning. We're waiting for the director to give us the cue that we're actually live here.
The lollipop.
Oh,
I'm angry at the lollipop.
Hi, everybody. This is Alex, and this is my blue-haired friend, Sebastian.
Hi. I'm a Smurf.
We are here with Tech Tuesday number 2.
Don't forget Alexis.
Alexis is our director, and we are going to do an intro of her at the end of this class. If not, I'm going to get in trouble again.
Yep.
So, last time, I hope you are all here or have caught up on the live stream, but last time we did something really exciting and sort of boring at the same time. It was interesting because we learned how to turn on a light on a board and how to control it through some code, but you know, we all have the ability to turn on and off light switches. So
Why
there was
is it still on ground?
We'll figure it out.
Okay.
We'll get there. It was interesting because, you know, we got to do it through code, but we all turn on light switches at home. There's nothing really new there. So today we're going to take that one step farther, and this is where electronics gets really exciting. Before we turned on one light, today we're going to use this cool little device, and each one of these little dots here is a light.
And you can program it to like turn on special ones at a time, like certain ones. You can do that one and that one and that one and that
so
one.
we can make pictures.
Yeah.
We
did the smiley face and heart.
Well, we're gonna do that today.
Frowny face and heart, and we're gonna do that today also.
Don't give it all away.
Sorry.
So yes, we are going to show you how to make pictures on here. The cool thing about this is then we're going to also combine this with another sensor here, which is a proximity sensor. It's a big word, but proximity just detects how far away something is. So when you get closer, this is going to send an alert to our board, which then that alert can say to change the picture on here.
How does it do that?
Well, I'll get to that when we start talking more about the sensor, but I'm excited to teach you about that too, because it's really neat.
Waves out, and if it comes back weaker, that means that something is far away, and if it comes back stronger,
let's get there when we get there. Let's get there when we get there. I know
smart.
we're all excited. For the last class, Sebastian and I had already done it before, so he really knew what was going on. With this one, I think he's a little more excited too because we haven't gone over this for him yet. So he's going to be learning as well. And just like you out there, he has a lot of questions. Feel free to ask any if you have any in the comments, and our wonderful director will get us those questions and we'll answer them on the air here. All right, so for this, we're going to start out with this board and we're going to program it to do a picture. Now, you'll notice on the top of this board there are 5 pins. We're going to want to put these in there. On the back here, there's one section that has pins that are VCC, ground, D in, CS, and CLK.
What about 5V?
Hold on. VCC, that's a really good question. So VCC is the same as 5 volt, which is the same as power. So whenever you see VCC, that's the same thing as 5V out of this board. So that's what the power into this board is. When we talked about circuits yesterday, power has to come into this board on VCC, and then it's going to go out through ground. And then the lines that are the wires that are going to control this board are your D in, your CS, and your CLK. Okay. So we want to put this. We're going to stick this into our breadboard over here.
Bread?
And you're going to stick this in.
Why is it called a breadboard?
I don't know. I really have no idea why it's called a breadboard. That's a good question.
Maybe because it has holes like bread?
No, you can't really eat it. I would not recommend it. When I say can't really, I mean absolutely not. You cannot eat it.
What do you mean you don't recommend it? Have you tried it?
No.
Good.
So we're going to put this in. Again, the side with D in is the side that goes into the board. D out is if you actually want to chain these together. You can get more and more blocks of these lines. So D out comes out of this to another board.
Each of them, so if you wanted to chain them, you could have like 8 and you could write a word. Like each one of those is a letter.
Correct. And so, but right now we only have one. So Sebastian, will you do the honors and put this in here? Now, switch over to the breadboard scene. And so we're going to put it in any row you want over here, not in the red and blue row, because that's where power and ground go. So pick one of these. That's a perfect spot. Make sure DN is in there, and just push it down.
What do you mean DN?
Make sure you're using the side that says DN over here, which you are.
Wait, what?
The side says D. One of the wires
Din.
says DIN. Yes, DIN.
Can I put it over here?
You can put it wherever you want.
Up.
That's a perfect spot. Now, okay. Some of these breadboards are actually really hard, and it's hard to get in. So if you actually, you're going to want to put it towards the front. Now that I think about it, you're going to want to put it somewhere where you can put wires behind it. So let's put it up here.
Like this?
No, turn it around just how you had it before. There you go. And push. Yep.
You do it.
Parental help is okay. So when you get it in here, the wires or the metal contacts are in the board.
Can I peel the plastic thing over the...
Sure. I know everyone loves to peel plastic things off.
It's so satisfying.
What? All right.
Oh, this is so dirty.
What?
This is
When it
just
froze?
dirty.
Is it working or glitching? Okay, it's gonna go slow. That's all right. Okay, hopefully everything's here. Okay, so one of the important things here with this breadboard is we need access to these pins back here. So try and put it up towards the front so that way you can put wires back here that are going to connect to the signals that we need to connect to here. So now the next step is really wiring this into our board. So we're going to bring our Arduino board over.
So that ground, we put it in here?
I would put it in the back over here.
Right here?
Yep. And then here, put in your VCC. So again, we're going to wire this very similar
5V.
to the board we did yesterday, or last week. So ground is going to go into the negative side of the board.
Wait, what?
VCC, or 5V, is going to go into the red one.
Power.
And that's our power.
I
Now,
have power!
now from...
I will rule the world!
Never give this boy power. Okay, so now we have power and ground coming in here, and then we'll need another wire going from power to ground over here. The importance of doing power and ground here is the fact that later on we're going to have our sensor here, so we already have
Another
power
wire
here.
prepared.
We don't need to keep doing
This
wires
looks like
from
a
here over.
helicopter.
Let's not talk over me. I want to try and explain this. All right,
I
so
want to play helicopter.
can you do the ground from there,
Your turn?
from the negative side?
But
And now
I-
you're going to have to look where the ground is. You can lift it up. And now put it into the same row wherever it says ground. Can you lean? Oh, well, he
Row or column?
can. Just behind it. There you go. And now we need
Is
to
it working?
No, because we don't have any power to here. Remember, we need to complete
Plug
that
it in.
circuit. We
Plug it
need
in.
no. We need all the wires in. Let's do all the wires first. All right. So this is the not most exciting time where you're putting in
VCC.
wires. The neat thing about this, though,
I'm putting it in VCC.
yep, that's where it goes. The neat thing about this is, and what makes this so exciting, is that last week we had one wire to turn on one light. What we're going to start learning about today is how to use one wire to control a lot of lights. And so let's do,
Wait, I thought that's 2 wires.
well, it's going to be 3 wires.
What?
There's clock, CS, and D in. What?
Barbara Ann said we don't have sound.
You don't?
Is there no sound?
I guess so.
Hold on.
What? How
I can hear
dare
him. Maybe restart the video.
How dare sound?
If you don't have sound, you're missing everything.
We have sound.
Okay. We have friends too. That's the most important thing.
Wait, where?
Well, people are watching and commenting, so I consider those people friends forever.
Yep.
You can be my friend. All right. So, yeah, you're too young for that. All right. So now we have 3 more wires over here. We need to select any pins from here. And so
Let's put it on 1.
you can use 1, 2, 3, 4, 5, 6, 7. Use any pins you
Or
want.
13.
Okay. That's ground.
We did 13 last time.
But you picked ground right there.
Wait, what?
That's ground right
What's
there.
wrong?
Pick 3 pins.
Pick 3 pins back.
12,
Any
11,
3.
and 10.
Okay. So really you can just do 12, 11, and 10 and just put them into the next 3 holes over there. So what I was saying, hopefully everyone...
Do I plug this into 11
Sure.
and 10?
Sure.
Ow,
Oh.
pokey.
Pokey.
Make sure not to hurt yourself.
The wires are pokey, people. We're going to have to watch out for pokey wires.
That hurt.
I'm sorry.
Does it go on clock or DIN or CS?
You get to choose. In the program, we're going to tell it which wires we hooked up where. So you have the flexibility. That's the neat thing about this board. It's programmable. We can say we hooked it up to these pins, and we'll go from there.
What's the difference between all of them?
Well, I'm going to explain that. So, like I said, last week we had one wire controlling one light. So that wire went on, or that wire went off, and if it was on, the light went on. If the wire was off, no power, the light went off.
No.
Plug them in, come on.
I love power.
So,
Wait, but there's only 2 holes.
there's 3.
No, there's 2.
Hey,
Come on, bud.
flashing it.
There's one right
It's okay.
there.
No, just put it, okay. He's got to get it in, though. Put it in any of those rows, bud. So that goes in one row. And then, okay, well, I know his hair is beautiful. Hopefully everyone is really enjoying the scene right now. We're
Do I
trying to
put
get those
it here?
No, you put it next to it. I see what you were saying. So one wire goes into the D in, one wire goes into the clock,
Wait.
and we'll hold it up in a second. That's fine.
Oh, so I put it the other direction?
You can put it wherever you want.
You said one goes in DM, one goes in CS?
Yes, I did. And so one goes in each of those. Put one in.
Pokey.
Pokey again.
It poked me again.
I'll hold this up to the camera so you guys can see exactly what we're doing. Make sure we're all on the same page here.
Just a bunch of wires fighting. I can't get it in. The
All right.
wire is just bending.
Yeah, they do bend. Some of these wires are not the highest quality, so we've had some of them already fall apart on us. Hopefully you guys have better results. I'm actually going to replace this wire and get a different one.
Let's do blue.
Sounds good.
I like blue.
Well, let's go.
Blue. This
Okay.
is longer.
All right. While he gets that set up, I'm going to explain this a little bit more. Shh, let me explain, okay? Please, let me explain.
Okay.
All right, so there are 3 wires here. There's a clock, there's a CS line, which we're not really going to go into right now, and then there's a D in. D in stands for data in. And so how this actually works is the clock is a wire, and all it does is it goes high, low, high, low, high, low, constantly. It's a clock, so sort of like a clock ticking. It ticks, tick, tick, and every tick is when it either has a high voltage or a low voltage. And the way this works is that the data line sends data at the same time as the clock. So every time the clock goes high, the lit up board looks at the data line and says, okay, is it high or is it low? And the first time you have data, it might turn this light on.
Which
then
one are you pointing
just the top corner.
Okay.
Then the next clock, the tick, the data pin is going to tell whether this pin is on, whether this light is on, and it's going to keep going like that. So clock, 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 clock. Would you fix that, please?
Sure, I didn't mean to.
I accidentally.
Oh, I'm sure it's a little bright right now.
No, it's not that
Come on.
bright.
All right.
I'm sorry if you still don't have sound.
Okay.
Oh.
It doesn't matter about that one.
It's still good. All right. So the whole point of this is before it was one light or one wire for each light that we were trying to do. If we needed to do that for this, it would be 8 rows times 8. It would be 64 different wires that we'd need to plug into this. Fortunately, we just plugged in 5, and we can control all 64 of these.
Because there's only 5 pins.
So again, the way that it works is that clock, tick, tick, tick.
Tick, tick,
This
Tick-tock.
right here, there's some logic inside of here that says, okay, the first time that clock ticks, I'm going to look at the data line. If it's high, this light goes on. If it's low, there's no voltage there. This light goes off.
Or that
Then
one
the
goes
next
on
the next tick, this one goes on. Then the next tick, this one goes on or off. Then the next tick. And so it does it 64 times. And once it gets to this last one right here, the last tick of that clock, it starts over up here. And the amazing thing is you know, that's...
It does that super duper fast.
It does that super duper fast. That's what's so impressive.
In less than a second.
That's what's so impressive is the fact that this board does that not just hundreds or even thousands of times a second. It can send that clock millions of times every second. So you can update these lights instantly quick. It's how a TV works. It's how it's how computers work. It's how almost all electronics work. They don't have a wire for every pixel in your TV, every little dot. They just send data using a clock and the data, and the processor inside there figures out how to put it together. So now we're going to turn this on. Let's plug this in and make sure we have all our wires correct. I'm sorry, I didn't actually show you guys. This is basically what we're going to want to do. We want to have the red wire here is going to be our voltage. Then this one is our ground. Can you see it? Which way? Is that better? Okay. And then we have 3 wires over here. And these 3 wires are red, our white, and our blue. You can use any color wire. Those are plugged right into our Arduino board.
It looks like it's bleeding white goo.
Yeah, I hope it's not bleeding white goo. Those are plugged right into our board here in pins 12, 11, and 10. And so we'll hook those up in a minute into our program to say, okay, we're using pins 11, 12, or 10, 11, and 12 to control this board. So that's what we're going to do next. So will you plug this board in?
Pluggy.
And we're going to go over to the PictoBlock software.
Ooh, it's just all bright and on.
Melissa Andre says, can you set the rate of the clock to slow it down?
Hi,
that's
Mommy.
a really good question, Miss Melissa Andre, whoever you are, good viewer and follower of ours.
You are her husband.
Thanks for reminding me.
She's your wife.
So,
Hi, Mommy.
in the program we're using, we can't set the speed of the clock. If you really want to control over it, you can write the code to actually speed it up or slow it down. But for our purposes, we don't really care about the speed of the clock. What we want is our picture to show as fast as possible. And you'll see really quickly here. You'll see really quickly here that it will change as fast as we want it to change. So, do you have... What's wrong? It froze. Okay. Hold on.
Remember the thing?
Yep. I got to do my thing over here. I know. I'm sorry. Is that working?
No.
You might have to flick away and flick back to it. We have to fix the camera issue that we have here. We'll try and get that better. Go to a different view and then come back to it. So
Sorry, you might go to the computer or something.
that's fine. Our director will figure it out. We've had 2 days of experience with this.
2?
2 whole days. Is that
One
looking
day,
good?
and this is our second day trying it.
Okay. So now in our PictoBlock software, we're going to come over here. I just opened it up. And again, okay. Oh, I stole the mouse from her.
Apparently,
made her
she
angry.
really likes it.
Okay. So again, in the PictoBlocks, we have to go over here. We select the board that we're going to use,
Denso.
Arduino Uno. And this is going to start up. I need the mouse.
Why does it say serial ports like serial killer? It says serial
We'll talk about that
ports.
later.
Serial ports?
Serial port is how it talks. Actually, a serial port, amazingly, is exactly what this is. A serial port is sending data with a clock. So you have a clock and you have
My
data,
nose is red.
and that's how it's actually communicating to this board is over a serial port. So
That looks weird.
no killing involved. From here, I need the mouse back, sweetie. Okay, so over here, we're gonna click on this upload button over
Can we
here.
change the color of this
Nope.
to a different color?
This is set up just to be red.
It's not a LED light.
So we're gonna drag over our first block that we always have to drag over when we're programming
When
one of these.
Arduino starts up.
When the Arduino starts up, and then
Arduino. Arduino.
if we scroll down over here, we want to find the 8x8 dot matrix display. There's 8 rows of 8 dots, and we need to bring over the initialize block. This is where we're gonna tell.
That's a lot of code.
It is. It generates a lot of code over there. It's
To
nice we don't
decide.
have to write that.
Yeah.
So here's where we
Let's
say.
just click and drag 2 things.
Here's where we say what pins we actually hooked up here. Again, this is programmable. It doesn't know what pins we've hooked up here. So can you help tell me which, excuse me, which pins you've chosen?
We
So-
did 12, 11, and 10. Why is that weird light on? It just
I
turned
don't know.
on.
So 10, can you tell me what pin that goes to over there?
10 goes to...
It's the white one. And
10
so
goes
you can
to
read
clock.
It. You can read it up there. So
10 goes to clock.
we're going to do the same thing here. Or not the
Clock.
same thing. We're going to do this here. So
Clock.
10 goes to clock. Tell me where pin 11 goes. Once you get done yawning. That's a good idea. I'm going to drink some coffee while he figures out number 11.
It goes to CS.
Okay. And then that would mean that pin 12 goes to DN. And now the only other thing we have to do here is we can drag over this block here, which says what we actually want to display. And this,
Wait, you can just click any of those?
isn't that awesome? So you can select the heart, you can select the all on,
Or you
select
can
whatever
write high.
or you can write whatever you want. So
Wait, can you erase all of it? So
Yep.
do that and...
sure, do a couple, and then I want to actually program it.
You said it said DN. Why does it say DIN?
DIN is because it's data in. On the other side of that module, there's a D out pin. And so when you connect them together, the D out pin of one block is going to be the D in of another. So it comes out of here and goes into here. So D in and D out are very common terms.
Wait, no.
It looks good enough. Okay.
No, it
I see.
doesn't. That is horrible.
Well, you're not gonna like this anyways once you see what happens. So let's just do that.
Hi.
Okay, and we're gonna
Would
now.
it do it backwards?
Right now. Now over here, go to upload code. It's gonna build it, and then hopefully, let's see.
Switch to this cam.
Oh man, we're at 90%. Upload in progress. Here we go.
How do you know it's 90%?
There you go. Look at that.
How is that high?
So it is high, but here's the trick: is it's sideways. So when their things are rotating it, so it is high. I don't know what it looks like in the camera that's up top, and don't lean on the boxes. But so now it says high.
So if I do it sideways, it'll work?
This board was meant to be done sideways, so you sort of have to rotate it when you do it over there. I'm going to change this code over to a heart, let's say, just because that's what it defaults to.
What?
And if we do upload code,
Let's see what it is. 90% uploaded.
the excitement,
Heart.
there's our heart.
Wait, why is it sideways?
Again, it's going to be sideways. That's how it works.
It paused.
What?
It didn't.
Again?
Oh,
Is it working?
it's good.
Okay.
He touched something up there.
So now we can control this. Someone keeps stealing my mouse. We have one computer to control a lot here. So me and the director, we have it at odds every once in a while.
Yeah.
We're going to come over to control. And again, here's these different operators that we are different things we can do. And so we're going to say, let's do a forever loop. And we're going to say,
Again?
yep, forever loops are very, very common.
Why?
We're going to show the heart. And then after the heart, oop, that went a little far. We'll show,
Smiley?
sure, a smiley. And then back up here at control. We'll wait, Alexis, I need that, please. We'll do this. So basically right here,
Can I
what's
push
it,
upload code?
sure, what's it going to do now?
It is going to turn into a heart. Why does that look like an evil face?
I don't know.
No, that's a weird heart.
But
Okay, it's gonna turn into a heart, wait 1 second, and stay on a heart for a second, and then go to smiley face, and then it is gonna wait 1 second, and then just go back there and keep repeating forever and ever
Sure.
and ever and ever.
you forgot to do upload code, the one thing you really wanted to do.
Upload code.
So
I don't see what this does.
this is a good example. We had the question from some wonderful viewer, if we could control the speed of the clock. This shows you how fast it can actually go from one picture to another. It is actually changing all 64 of those so fast, I don't think you can even see them changing in progress. That's how fast that clock, that tick, 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 is actually going. And like
It's
I said,
going like, and
yeah, I mean, it's pretty much, it's going very, very fast.
it's
and
pretty
it-
much like,
Yeah, that's beautiful sound.
Or this.
Okay, yes, all of those sounds are perfectly accurate for it.
Really?
Exactly what it sounds like.
Can you put it up to the camera?
Sure.
Wow.
So hopefully you can see that. And so now we know that we can control that light. And if you've seen the video already, let's put it back down.
Move your hands.
Now, if you've seen the video of what we're going to do next, we're going to use the sensor.
But do we have to make it sideways?
If people at home want to adjust that picture, they can. We're not going to sit here and click them all. But for now, we're going to go on to the next part of what we're doing.
Why does it do it sideways?
Because it expects another board over here. So it's
Wait,
meant
it
to do like hearts in a row, let's say. Or if you want to do high with H and then I, it's doing it. We actually rotated it the wrong way, but that's how it works in this breadboard here. But as you saw, you can click those little lights and change it to however you want.
And if you unplug this, it all stops?
Yep, let's not unplug that right now.
Okay.
So now we're going to go to this next board.
Sensor.
Again,
Let me hold it.
yeah, we hold it up. Now, how many pins does that have on it?
It has 4 on one side and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10,
just the
11.
pins
A
that we're
bunch on
plugging in.
here.
Okay, so
It has 4.
this is our distance sensor. The way this works is there's a pin called trigger.
Looks like a weird speaker.
It's a really good example or good
Send-
definition. I can't talk. So there's a trigger pin, it's called trig, and a pin called echo. And what's going to happen is when you send voltage on the trigger pin, this speaker right here is going to send out a sound. It's going to be really, really, really high pitched. You cannot hear it. Dogs can't hear it. It's not something you can hear, but it's still sending out sound waves. Those sound waves are going to come right at you at the camera and then bounce back and hit this one. And when this one gets hit, the echo pin is going to send a voltage that actually goes into the board. The time that it takes for this sound to come out, hit, and reflect, there's a time in there. And you can use that time to figure out how far away the thing that it hit is.
I don't want that a heart.
Okay, but let's Sebastian, come on. We're not doing this now. It's
I'm
okay.
just doing full.
Okay, perfect.
Why not?
So the nice thing about this drag and drop system is you don't have to do any of the math. You don't have to do any of that work. There's going to be a really simple block that you drop in there that says, trigger this, tell me how far away it goes. And so we're going to work on that. Again, we have 4 pins that we have to work here to do a lot of really cool stuff for figuring out how far something is away. And then we're going to use that distance to change the light on the board.
Why does it say MegaCon Orlando?
It's an email. We're going to MegaCon Orlando, everybody.
Woo! We are?
Well, I'm going to MegaCon Orlando, everybody.
When? We can't because coronavirus.
We'll figure it out. All right.
Froze?
Yep. Is it? Hold on, everybody.
It
All
froze
right,
again?
do your thing. Okay, so
Froze?
now
How dare you?
you're going to have to change the scene and go back to it. That's what usually kicks it back up. So now, Sebastian, plug this board in.
Why did you just unplug that?
And let's plug this, because when we're plugging a new board in, when we're plugging something in and putting wires on it, it's best to not have wires going to it. 'Cause, hey, come on.
Finally.
People can't hear when you do stuff like that. It's best not to have wires, be plugging in wires when you have electricity going to it, because...
More wires?
Yep, so now we need to do the same thing. Voltage, ground, trigger, and echo. So we need to hook those 4 pins up.
No, we just do it from...
Yep, we already have our voltage and ground over here.
But what you said, like, if it's halfway...
This board's different. I got a different board because that was confusing before. So use your voltage and go to voltage.
Sure, why not? This is negative.
It's best not to hook up wires while the board is powered. You can do it, most likely. If you do it right, if you're hooking the wires into the right spot, you're not going to hurt anything. But if you make a mistake and you hook voltage into ground by accident, bad things are going to happen. So it's best to wire things up when you don't have electricity going through there. And,
Where do I plug this into?
well, if that's your, that should go into ground.
No, that's...
So look at,
Okay.
Move
Okay, so... Brown.
so
Hi!
voltage and ground, just so you know, these boards,
this
it'd be
one?
really hard for you to hurt yourself with these boards.
I just hurt myself and poked me.
Okay, well, poking yourself is different. It'd be really hard for you to hurt yourself with electricity with these boards. If you're not careful, you're going to hurt yourself a lot. There's a lot of spiky parts. But this is where.
Be careful.
Okay. But the electricity going through these boards is really, really low. It's just a couple of batteries. It's about the same as 2 or 3 AA batteries, and you really can't hurt yourself with that.
Brandon Kirk says, "What happens when you do that?"
When you and that's
When you get
it's a good question.
electrocuted, it's
Well,
not very good. It's
not electrocution. Hold on, let me explain what he's asking. So
I don't know what
if
he
you
does.
connect power to ground, then you have what's called a short circuit. Please hook up the 4 wires.
okay. So
You have what's called a short circuit, and the power goes immediately to ground, and things get really hot then, and something can break. If you have this hooked up to USB through your computer, let's say, you can hurt the USB port on your computer. Generally, the USB port on your computer doesn't supply enough power that it can do anything of damage. It can't even usually hurt your USB
I
port,
forgot what I do.
but you don't want to take a risk with your
I
computer.
forgot what I do besides the power and voltage.
Two wires into one of these digital pins here. Okay, that's fine. We're at 30 minutes. We're going to go a little long today. That's okay. But so
Whatever, who cares? Let's put this in
hooking up the wrong pin,
number 5.
the outcomes of that for especially something of this power, you're probably not going to hurt anything, but it's best not to do it. But for the 8x8 grid, it's possible you could short. You
Does
could
this
create
go
a short.
in trigger or echo?
You choose, because we're going to program it later and say.
Okay.
You
do
could
I
break.
put both
You
of
could
them?
break that LED. You could break the distance sensor. You could break something, and then you have to buy a new one. These are $2 or $3 a piece if you had to buy them individually. So it's not end of life. A really important thing with these is to experiment. Honestly, the toys and the elements that come, I call them toys because they actually are really fun. The sensors, the different things that come in that box, I want to sort of explore new ones each week to show you how you can start using them together and what they do. But really, once you see the code, hopefully you come up with new ideas. Like I was saying last week, you can do a sensor, and if someone enters your room, it can set off an alarm. Or, with the happy robot here, when you're close to it, it's going to smile, and when you get far away, it's going to be sad. You can do a lot of different things with it. I want to explore how each of the sensors work. But really,
Echo is-
don't be worried about hurting anything.
Echo's
It's
in
the most
2
important.
and 5 is on trigger.
Okay, so you got that. Okay, so this is going to take a little bit more blocks of coding here. Do you want to plug it in? What?
Sure.
Yeah, let's go back to the coding blocks.
Pluggy.
All
I
right.
love to plug things in.
Anywho.
Wait, what?
All right.
I'm putting my hand on here. It's not doing anything
It's
because
not
we
going
don't
to.
have
we,
code.
We haven't done any code. So we're going to go over to the Arduino.
Why can't
Uno.
I just read your mind?
When you program that, we will definitely have a seminar on how to do that because
What's a seminar?
live stream because I can't wait to see how to program that. Yes.
Melissa Andre says, "Can you show a close-up of how you've done the
Oh,
wires?"
Yep. We hold that up. So
Actually, I'll unplug the
No,
other
don't
red one
unplug 'em.
and trade it with a black one.
it's okay.
Okay.
Let's not unplug it for now. Let's just
Close up.
again.
Echo.
You gotta tip it over so they can see. So again,
You
here
froze?
we use. Is it working?
Yeah, but you can't see all the wires.
Oh, okay. So
How's that
again,
doing?
we have the 4 wires in a row over here. We didn't use the red and green. She's helping. We didn't use the red and green for voltage and ground. That's usually, it's tradition. It's not required. As you can see, the wires don't care what color wire or the voltage doesn't care what color wire it's in. But so we have our voltage and our ground, and then we have an echo and trigger pin hooked
And
up
just
there.
a lot of wires
And
flying
it does look like a lot of wires.
Do we need any more wires?
Nope, that's all we're going to do for wiring this week. So
Yay.
hopefully we're all on the same page there. Let's put it down, stop moving it so much. Okay. So,
I wrote
someone
in
stole
now.
my mouse again.
Oh no.
So I can see the comments. I'm sorry.
All right. I think sensors is where we're going. Okay, yes. So if you click over here in sensors,
Our director is doing a mad dance.
she is a dancer.
Yeah.
There is a read. No, that's not it. Where is it? What are we looking for here? Oh, please don't make those noises. There is one. Where are we looking? There's one in here that's meant for reading the
Sensors.
servo, connect motor, ultrasonic distance.
Wait, why are those highlighted?
That's what we want. We want ultrasonic distance, but there's got to be something missing here. Huh.
What?
Well, we're missing the.
How can you even see things when they're going that fast?
Well, I'm pretty darn good.
No. Actually, never mind. Whatever. Sure.
Okay, I'm not sure why I can't see this. I'm not sure if the rest of you can. Over here, there should be. I'm actually going to open a different project that I have.
Is it the other one?
I don't know. Hold on. Let me
Friendly robot face. You literally named it friendly
see.
robot.
I did, and it worked. So we should have a. Okay. Let me go back. Let me see if I can generate that again.
Do you even remember what it says?
Yes. Okay, I'm gonna have to rebuild that. I was a little slow on what I was doing and forgot what I'm doing. Okay. Apologies. We all make mistakes sometime. All right, we're gonna initialize. I need the mouse, sweetie.
Give the mouse back.
All right, so we initialized this. This was, I believe, 10, 11.
I'll check.
Okay, and then
10 is clock. Yeah, so you got it all right.
okay. So sorry about that.
It's fine.
Okay, so what we want to do here is we are actually going to set a variable.
What's a variable?
A variable is something that just holds something that changes. So a variable, for us, it's going to be the distance that the sensor finds. So we're going to constantly update that variable as the distance grows or it sees a new distance. It's going to update that variable.
Can I drag it?
Later on, yep. So
one?
set my variable. Just drag that over.
Oh, I don't have to click. Oh.
Yep.
My variable.
And we're going to say,
Do I type it?
you can rename it. Just say rename variable, and we're going to say, we're going to name it distance.
Why can't you name it hello?
You can name it whatever you want,
Name
but
it hello.
distance makes a lot more sense than hello. Okay, and then down here, there's a, you can see this has a little oval shape in here, so we have to find an oval shaped block that fits in there.
How is
And
that?
this says get ultrasonic sensor distance in centimeters
But there's
from.
other oval shaped
There's
ones.
other ones, so we can get different. We can use different sensors
Why
to
is
get
there
different
a
values.
triangle?
You got to let me answer your first question before you ask more questions, okay? So this
I have a
one,
lot of questions.
I know you do have a lot of questions. I'm very used to that. All right, so this says get ultrasonic sensor distance from trigger. What pin did we put our trigger in? Can you tell me
Trigger?
what pin number is that?
Twigger? Twigger is...
What?
Wait. Trigger is 5.
Okay, so now we go down here to pin 5, and echo is,
Echo!
it's a pin number, not a
Oh.
song. Oh,
2,
our Alexa just said hello.
2, 2.
Okay, so
Why
now
isn't there a 1?
we're gonna set our distance to whatever the sensor comes out to. And then this is where we actually go back to control, and now we can actually start doing some logic with
Why
this.
couldn't you have chosen 1?
We could,
There
because
was no
you were
one.
the one. You were the one who chose
There
the
was
pin.
no 1 on that.
I don't know. That's a good question.
Ticket.
I don't know why there's no one. That's an excellent question. I have
Well,
no
maybe
idea.
because it says 1TX
Yeah,
with
maybe
an
that's-
arrow pointing.
That might be a special pin that we can't use. So I'm glad you didn't choose that. So these are our pins. Again, your pins may be different. So now we're going to say if, and we're going to do, oh, actually, I take that back. We want an if-else block. So we want if,
What do you mean If else.
It says if and else here. So we're going to say if the distance is a certain amount, we're going to show one face.
15 centimeters.
Sure, that's a good guess, or a good
100
starting
centimeters.
point. So we come over here to variables.
Oh. Melissa Andre says, what is the echo for?
You were not paying attention earlier. The echo is
Maybe she was just watching the movie with Nathan.
The trigger pin sends sound out of one of the speakers, and the echo pin is what listens for that sound to come back. So this little blue block takes care of all of that for us, which is really nice because you don't want to write all that code. But it will, when you have this block here that says get ultrasonic distance, it's going to send a quick burst of sound out on pin 5 for us, and then instantly start listening for that sound on pin 2. And it's going to do all the math to figure out how long it took for that sound to get out and come back, and it's going to put that value into the distance variable. So now we come over here. Okay. And we say we're going to want to do if, we want to go to operators, and we want to pick, we're going to put something like this in here. So
60?
This means,
50.
I'm going to have to sort of drag a couple things over here. So you want to drag in the operator that's blank is greater than a number.
But since, they're not all the same.
Yep, some are equal, some are different things. And then we want to drag our distance variable in there. So now we have something that says set the distance according to how far it is, and then if the distance is greater than 50, we'll lower that down to 15, because up here it says we're taking it in centimeters. So 15 centimeters, about that long. So now if something is closer than this, we are going to display, I'm going to have to drag my
But it'll do it sideways.
Smiley face over here.
It'll do it sideways.
It will do it sideways, and we're going to have to live with that for now.
Or I can click it and draw it the other way.
You can when we're all done with this live session.
Wait, no,
You can play with this all. You can play with this all of April. We're not going to do it right now.
I know a very fast way.
We're not
you
gonna do it
can
right
just erase these and there.
Okay,
And
Sebastian,
uh,
come on, bud. Come
no,
on,
I need the
Okay.
boobies.
Sebastian. We want to finish this up.
Do it.
Okay, so we have a smiley face. Or actually, we're going to do a sad face because this says if distance is greater than 15, we're going to be sad. And then else, if we're closer than 15, it's going to be a smiley face.
Or 15.
And there's one last thing we need to do over the top of this. We're going to go back up to control. And we're going to put a forever loop around this.
Yeah.
So now, if we follow this code, it starts up, it's going to initialize the
I
display,
want to push upload code.
and then forever, we're going to
Upload code.
go for it. Forever, we're going to grab the distance, see if it's greater than 15, and if it is, we're going to show a sad face, or if it's closer, we're going to show a happy face. Yeah, show the board, please.
Why not?
Come on, upload in progress. Is it working?
It's not uploaded.
Yeah.
503? Yeah. Uh-oh.
Saying 503. Oh, try it again. Flick back and forth. I don't know why our upload is not working. Okay, go for it. We're almost done here. The magic's about to happen.
Really?
Okay,
Taking
our
like
thing just
5 or
said
6.
upload failed, so let me try and do that again. Oh, I need the mouse. Always trying to steal my mouse.
Mm-hmm.
We need to, I had the wrong board selected here.
Evil mouse stealer.
Oh no, what happened to our project? Okay, well, our project just got blown away.
Because
So-
you said disconnect and
Yeah.
you didn't save it.
All right, I'm gonna try and build it again really quick. Hopefully
Why is
you
it
guys,
so small?
hopefully you guys
You
have
didn't
been able
do
to
it
program
forever,
yours and everything is good. I'm gonna try and rebuild this again really quickly, lightning speed.
This
Let's see
doesn't
how
look
fast I
very
can do it. 11, 12, and we're gonna do forever. Forever. We want to. This is same thing that, oh yeah, variables. We want to set our distance variable.
What does change mean? It says change variable.
I don't know. Right now, I just want to get this going. Where was our get ultrasonic distance? Sorry, everybody. Do you remember what our 2 pins were? 2 and 5?
Yep.
Pretty sure.
Yep.
And then we're going to zoom right along here. And we're going to show again oh, I forgot my if else. Nope, just a moment. If our distance.
No, you have to do frowny face.
Okay,
Wait, what?
I'll get there.
I'm gonna do frowny face.
Just hold on.
Can I make it where frowny face is?
You need to let me get it set up again, Sebastian. All right. If our distance is greater than 15.
Can I make that?
No, you're not. Like I said, you have all April to play with this. You can play with this every day until next Tech Tuesday. And
so I only have a
there we
week?
go. So let's try and see if this works better. Hold on. Connect. USB modem. Sorry, everybody. Hopefully we caught up.
Code.
All right. Let's see what we got here.
You ready? Is this sideways, Alexis?
Who knows? We'll never know.
Is it sideways?
Upload in progress. All right. Now we have a sad
Is it
face.
sideways?
Okay,
I
that's
don't
fine.
know.
This is everyone wants to see whining and complaining between brothers and sisters. Okay, so
What?
now
Why is it like flickery?
that's a really good question. You got to move your hand a little bit, bud.
Flickery.
Okay. Okay. So as you can see, you might have the same flicker, and we had this before too, where it goes really fast. There's one more thing that I'd really recommend you do to make this so it doesn't flicker as much. The problem is that this trigger, it does send out a pulse really quick, but it's not always perfect. And so what we really want to do is actually pause whenever it sees the bad distance, or whenever it sees whatever we like. So if we put just a little pause down here of 1 second, so now if the distance is greater than 15, it's just going to keep going, and it's never going to pause because it's always waiting till it sees someone close. Then when it sees someone's close, it's actually going to. It's going to keep the smiley face on a little bit longer, and it's going to get rid of that flicker for
Why
us.
is it doing it?
Just hold on, because it hasn't uploaded. Now try it. See, now when we do it, that flicker goes away. There is a little bit of a delay. If you'll see his hand going over it, you're going way too fast. If you see his hand go over it, but that pause
This is
right there,
15 centimeters.
that pause right there really makes everything a lot better.
That's 15. Oh, I was moving my hand a lot.
Some things to note about this sensor: it is not the most accurate thing in the world. If you say 15 centimeters, it might register at 17 or 18 centimeters. It might not register when you're at 5. Distances really long also don't work, at least with ours. I think it sort of depends on how the quality of the board you get. So if you try and measure something 100 centimeters away, a foot, 2-3 feet away, it might work, it might not. You'll have to play with it and see. But at this point, we have managed to connect 2 really different boards with just a couple of wires, 3 or 4 wires each on top of the power and ground. And now we have a sensor that can detect how far away something is and control a bunch of lights
It's
from there.
my face.
And we've made Sebastian really happy.
I have power.
We need to get out of the house. So that is it for this class. I don't know if there's any other questions. We will definitely be here for Tech Tuesday next week. And I have one special introduction that needs to be done. Come on around here, Alexis. This is our director.
She was
Scoot
switching
over.
all the cams.
This is our director, Alexis. She's been awesome. Every compliment for directing goes to her. Every problem with directing comes to me because we're all learning this together here. I thank you so much for being with us. I don't know what the project is going to be next week. I'm going to go through the sensor kit and sort of figure out where we can elaborate from here. Because now we can do distance, we can do lights. I think some really cool way to bring them together with probably sound is going to be a good one, because there's some really cool stuff you can do there with alarms. You can hug me anytime. That is it. I really hope you enjoy it. This will be up on YouTube soon. Like our Facebook page. Subscribe to our YouTube channel, do all those wonderful things. Thank you so much. And we do have a YouTube channel for Pressure Games.
Yeah.
And I will see you next week. Thanks a lot.
Bye. Hope you come next time.